Okay, now I'm gonna sorry. Okay, now I'm gonna explain about the sum of probabilities. But first, sum of probabilities has two types. The first one is joint events, where we could have two events at the same time, or you might say it's overlapping, and also disjoint event. Okay, the first thing that I'm going to explain to you is the disjoint event. Um, it's pretty straightforward. You've seen it many times in high school, for example. Uh, yeah, it's easy to express this. So disjoint event, let's say you have A and then you have B here, uh, is symbolized but with this expression. So this disjoint, okay? This is disjoint event. For example, if we draw this in a diagram fan, for example, you have this, okay? Let's say in your hometown, okay, most are native. For example, this is most people are native here, and this is circle where it's non-native. Okay, here you have 30% of them non-native, and then 70% of them are natives, and then the total population is 100%. So this is exactly where you want to represent A, and then you want to represent this as B. So this is exactly what I'm trying to explain here, that you can express it in A, uh, B here. So the probability of A union B here, it's equals to probability of A plus probability of B. Okay, and then for another sum of probability type, which is the joint even. Okay, there is an overlapping part between these two. I'm gonna give you the example. So let's say I have this simple example, the same, and well, let's say we have population of student in our class, which consists of 100% of students, and 60% of them love to cook, okay, and 50% of them, okay, love to um, dance, okay. So this is what intersection is, and usually we can express this with probability of S intersection of P here, okay, and this can be calculated by some. Wait, okay, so we have probability here. uh it, this is intersection, okay, A intersection B. So usually, for example, if there is a question asks you about uh, what is the probability of a student who loves cook or dance, this is the common problem people ask. Then, or mathematically, it can be expressed as this. Uh, and then the way you calculate this, sorry, I'm sorry, this is C, this is tens, this is C plus tens here, and then this is C intersecting D. Yes. So one way to do it is by sum here, and then the most important thing here is you gotta know the information in this overlapping area. Let's say you know exactly C intersection D equals to 30% of them. So you're gonna have 30% here. So this is 110 minus 30 is equals to 80%. So you can easily say students who like soccer, who like cook and dance or dance are 80%. So that's the percentage uh, of this problem. Okay. The concept of overlapping or intersection can be applied to express the independent event in probability. So what is the independent event here? So for example, here we have A intersection with B. It can be expressed with this. Okay. So independent event means one event doesn't affect the result of the subsequent event. So the probability of this independent event is the multiplication of the arrays of the event. So for example here, uh, so if you have a coin, so coin again, so coin here, uh, we know the probability of coin to get head or to get tail is 0.5, correct? And then if you toss the coin 5 times, and what you will get is the probability of this just needs to be multiplied by 5. Okay, why? Because uh, if you toss the coin, then the result of the present after you tossing it doesn't affect the result of the coins when you toss it again. So that's what it is called independence. And the way we measure the probability is by simply multiplying it. And then you will get uh, the result. So another terms we use in probability is conditional probability. So usually we're gonna write this like this. Given, so the way we read this is what is the probability of A given condition of B. So this is given condition of what? Given condition of, okay. So let's go back to the simplest uh, coin example. So let's say you toss uh, 2 coins, okay, and you want to know what is the probability, of 2 heads appear, okay, given the first coin is head. So you want the first coin, so you want the condition, the result will look like this. Okay. What's the probability of the landing heads? Okay, given the first coin is heads. So if you look at this example, then with of the coin like this, what you're gonna have here is basically you eliminate this. Okay, okay, this has to be beyond our condition. I'm sorry. In mathematical expression, we can put it this at given the first condition of hat. Okay, so we only have this. Therefore, the answer will likely differ in terms of the denominator here. So you have had, so we only have one possibility that might merge. Instead of 4, you can use 2. So this is 0.5. So that's exactly the condition. And then the condition probability will be used in many examples in machine learning as well. And that's something that you have to be aware of it. And then, yeah, after this, I'm going to give you a slight explanation about the bias theorem. It's quite trivial, but uh, the intuition is really important to help us understand about the machine learning in many various applications.